All right, so the first one on FRQ number 2, test 1, it says the approximate this one. So what's the slope at 3.5? So 3.5 is right there, so you just have to take the slope right there. So I have the y2 minus y1, x2 minus x1. That's the slope at that point right there in the middle. So it's got 1.6, right? It's increasing because it's positive 1.6. And it says to indicate the units of measure, so I put on there ounces per minute. Now part 2, it says the slope also, is there a slope of 2? Well, we know it's 1.6 here at 3.5, so that means it's less than 2. And then I know if I put in 2 right there, so I put this one f of 3, f of 1 to find f of 2, and then I got that it's 2.8. So in between 2, it's greater than 2, so this is a 2.8, and then it goes to 1.6, so it's got to go to somewhere in between is 2 because of the mean value theorem. All right, so number 3, and I didn't put the mean value theorem, and I still get the full credit even though I don't say it, but anyway. So now this is the part where you all should get right. I don't understand why a lot of people got it wrong, but anyway, the midpoint sum is taking the first 3 here, so the distance is 2, and you take the middle one, 5.3. And the distance is 2, 11.2. Distance is 2, 13.8. So you have to have here 1/6 is the average, right? So it's 2 times 5.3, 2 times 11.2, 2 times 13.8. So that's the distance between it and then the midpoint. Distance between, midpoint, distance between and midpoint. And you could leave it like that. You don't even have to find the answer. That's just done much like that. And this means the average rate the cup is filled in ounces per minute from 0 to 6 minutes. So I didn't even fill this part out. That's just done. I don't have to do the simplification there. And then part D here, let's see, I didn't read it beforehand. Oh, I need to take the derivative. So it says here the rate, using this model, find the rate at which it's, so that means I have to take the derivative. So this is the b of t, I take the derivative, and I have to remember this 0.4 right here because the derivative up there has to come down. So now that I have this, I simplified it just a little bit, and because 16 times 0.4 is 6.4. And they're both negatives and positive there. So I put a 5 in there, and I get the 0.4 times 5 is 2. And then so there's my final answer, and it's ounces per minute. All right.